Good morning, class. These are our notes about zero product property. So we're still working on our study of polynomials, and today we're going to talk about this property and we're going to use it. So the property is that if A and B, so let A and B be real numbers. I know, and you're probably thinking that sounds weird, but believe it or not, we do actually have a thing called imaginary numbers. If A times B equals 0, then A equals 0 or B equals 0. So let's see if we can understand what's going on with this property. So what they're saying is if you multiply some stuff together and get 0, then one of those things that you were multiplying had to be 0 to start with. So let's think about what that's really saying. That's saying that if I want 0 for an answer, I have to multiply by 0, which makes sense. 8 times 0 gives me 0. Right? But if I do 8 times negative 0.001, I get something really small, but I don't get 0, right? Then I would get negative 0.008. So the only way I can get 0 is by taking that 8 and multiplying it by 0. I can't multiply by something really small. I can't multiply by something negative. I have to multiply by 0. So this is the property that we're going to be using. We're going to call it ZPP, and we're going to be using this pretty much exclusively today. So in problem 1, it should look familiar. We're used to seeing a problem like this. We know that those two sets of binomials next to each other mean that we're multiplying. And what we're used to doing is we're used to just multiplying those out. But we're not going to be doing that today. We're going to be solving. And so what we see here is we have this binomial here, 9x plus 2, times the other one, x minus 3. And when we multiply them together, it equals 0. So that means one of them had to be 0 to start with. So what we're going to do is we're going to set each of those things we're multiplying, 9x plus 2 and the x minus 3, we're going to set them both equal to 0 separately, and we're going to solve. Because one of those two, either this one had to be 0 or this one had to be 0. So let's go ahead and show our solving steps. We're going to subtract 2 on both sides here, and then divide by 9. The second one, we're just going to add 3 on both sides. And so x equals 3. And so our answer is really x equals negative 2/9 or x equals 3. So if I put 3 in here, 3 minus 3 would give me a 0 for that binomial. If I put the negative 2/9 in here, it would give me a 0 over here. So one of those two things had to be 0. So x has to either be 3 or negative 2/9. Let's try the next one. So the key is recognizing that I've got a bunch of things multiplied and that it's equal to 0. That's what I'm looking for. And do I have that here? Yes. I have an x minus 8 times an x plus 5, and together they equal 0. So we can use the 0 product property. And I'm just going to keep calling that ZPP. So that means I can take this, multiply by that, and get 0. So either the x minus 8 has to equal 0 or the x plus 5 has to equal 0. And then we're going to solve both of those. And they're really easy to solve, but I do want to see those solving steps. So this one I had to add 8 on both sides. This one I have to subtract 5. And so my answer is going to be x equals 8 or x equals negative 5. All right, the next one's got a little bit of a trick. So it doesn't have two binomials next to each other, but I do have a 6x being multiplied by an x plus 1, right? There's nothing between the x and the parentheses. When it's just sitting there, it means multiplication. So 0 product property again, it's equal to 0. So either 6x equals 0 or x plus 1 equals 0. Some years I have students kind of draw a line down through here, and we like draw lines where we're splitting up the things that are equal to 0, and that can kind of help. I just thought my handwriting was too big and it wasn't going to work today. So the first one I divide by 6 and x equals 0. The second one I subtract 1 and x equals negative 1. So my answers are x equals 0 or x equals negative 1. Okay, on 4, same thing. I'm multiplying a 3 times an x minus 4 times a 2x plus 7, and it equals 0. So each of these things we would set equal to 0. We would say, well, 3 equals 0. But wait, that's not true. So that doesn't give me a solution. Okay, I would say x minus 4 is going to equal 0. And then I'd add 4 on both sides. And then I would say 2x plus 7 equals 0. And I'd have to solve that one as well. So I tried to kind of show you what I meant by drawing those lines this time, but I really ran out of space. I think it ended up being too messy. And on that last one, we have to subtract 7, and then we have to divide by 2. So because this one doesn't yield a solution, it's because it was just a constant. It did not have a variable, and I actually could have just divided that constant out right away to begin with. I could also have just divided the 6 out on this one, but not the x, right? The x is a variable. The x gives me a solution. So I have to be careful not to just divide out letters like that, only numbers. You can only divide out constants. So on this one, we ended up with x is 4 or x equals -7/2. So we had two solutions here. And again, I tried to kind of show you how it was splitting it up for that multiplication, but I think it got messy instead. So we're just working on zero product property today, and then also going back and reviewing. In the next couple days, we're going to be putting more stuff together and learning on factoring. But make sure if you have any questions, you ask them in class.